How we do in AP Stat. We are in section 3 of chapter 3. We're going to be talking about quartiles, interquartile range, and box plots. All right, let's go. If we divide the data set in half at the median, we found out how to find that last time, then divide the upper and lower data sets in half at their medians, the three dividing points would be called the quartiles. You have three quartiles. There is Q1, Q2, and Q3. Q2 and the median are the same thing, and I will use those interchangeably. When I talk about Q2, I'm talking about the median and vice versa. This gives us another measure of spread called the interquartile range, right? That is a measurement of the range of the middle 50% of the data. Now, why is that? Well, if you look at how these data are divided up, between Q1 and Q3 is going to be about 50% of the data. It's usually not perfect, but it's about 50% of the data. The reason these numbers are called quartiles is because they divide the data into quarters approximately. Now, with small data sets, it's not as obvious, but with larger data sets, like one we're going to see in just a moment, they do divide the data up into quarters. Okay, so the middle two quarters would constitute a range of values. That range between Q1 and Q3 is called the interquartile range. We take Q3, which is 8 in this case, and we subtract 4, and that would give us an IQR of 4. All right, interquartile range is Q3 minus Q1. And we should note that quartiles are numbers, not intervals. A quartile is not an interval. A quartile corresponds to a number within a data set. All right, so for larger sets, it's more apparent that the three quartiles divide the data set into 4 subsets, each consisting of about or exactly 1/4 of the data set. For example, a data set of size 12, in order to find the second quartile or the median, you would find the mean of these two values, that's 5.5, and then you would look to the left over here, and you would need to find the mean of two numbers, and that's your first quartile. And then to the right, you would find your third quartile, which is the median of these two numbers. All right, for these data sets, we're going to be finding Q1, Q2, Q3, and the interquartile range. Just to note that Q2 is not considered when finding Q1 and Q3. So once you find Q2, you look to the data values below Q2, not including Q2, to find Q1, and you look to the data values above Q2, not including Q2, to find Q3. You can feel free to try both of these, pause the video, and unpause when you're ready, or you can watch me do the first one, pause the video, and then try the second one on your own, or you can just watch me do both of them. You choose. All right, I'll assume we're ready to move on. For the first one, number 1, we have Q1 is 2, Q2 is 6, Q3 is 10, and the IQR is 8. We see we have 7 data values here. That's nice and easy for a first example to find Q1, Q2, Q3, and the IQR. Counting to the middle, we would get 6 pretty easily for Q2. Then the values to the left of 6, we find the median, which is going to be 2. And then the values to the right of 6, we would find 10. So we have Q1, Q2, Q3. The interquartile range is going to be Q3 minus Q1, which is 10 minus 2 equals 8. Second one, same process here, except we have an even number of data values. We find Q2 first. That's going to be the mean of 6 and 8, which is 7. And then we look below 7. That's this data set right here. And we would say the median is between 2 and 4. That's going to be 3. And then for the upper data set above 7, so 8 up to 13, the median would be 11, the mean of 10 and 12, right? So again, our interquartile range is Q3 minus Q1, which is 8. All right, quartiles and histograms. Sometimes we can't do this perfectly, but we can learn a bit about the quartiles just by looking at a histogram. There's another kind of plot that we're going to talk about that makes finding quartiles dead easy, but that is to come. All right, the interquartile range can help us understand the data about this sample of 140 earthquakes that cause tsunamis that is graphed to the right. It fits a bell-shaped distribution that looks slightly skewed to the left. We talked about that last time. The median of the earthquakes is about what? Well, if we look at this interquartile range here, we have half of this bar over here and then a couple bars to the right. I'd say around 7.1, 7.2. I believe the objective correct answer is 7.1 would be our median. All right, if we were to look within Q1 and Q3, Q2 would be somewhere around here. All right, so we're going to say about 7.1. Q1 is about what? Well, we look at this bar right here. If this is 7 and we're counting by 0.2s, this is 6.8, 6.6 would be 6.7 right in between. And then we have 7.6 up here for Q3. Are there any outliers? This is kind of a trick question. How can we tell? Well, we're going to talk about that in just a moment. So how do we use the interquartile range to find outliers? The interquartile range is going to be our outlier detector, all right? So one definition of an outlier is any data value more than 1.5 interquartile ranges below Q1 or more than 1.5 interquartile ranges above Q3, okay? The value 10 in this data set to the right, this 10 right here, seems like an outlier. Can we confirm that it is? Well, in order to do that, we're going to need to find Q2 so we can find Q1 and Q3, find the interquartile range, and see if 10 is below 1.5 interquartile ranges below Q1. Okay, so here we go. Q2 is 22.5. These data values are in order. By the way, these data values have nothing to do with these folks up here. This sport here is a version of volleyball in which everyone is seated. What's interesting, though, obviously, is that number 2 over here is extremely tall. This is a Paralympic sport, seated volleyball, and this guy's one of the tallest people in the world. As you can imagine, he's about as tall sitting down as some people are standing up. So there you go. He is our outlier. I can't remember what his name is, but he's low-key famous on the internet. Okay, so Q2, 22.5. That is between these two values right here. Then we'd say Q1 and Q3. All right. 20.5 and 24.5 are Q1 and Q3. You can try this if you'd like. Check it against my work. But we can see here that the interquartile range is 4. 1.5 interquartile ranges then would be 1.5 times 4 equals 6. So we see that Q1 is equal to 20.5. The interquartile range is 6. So any value that is 20.5 minus 6, which is 14.5, of course, or below is going to be an outlier, which means 10 is, in fact, an outlier. And that is how we would show if a value is an outlier. That is a definition and the definition that you need to know of an outlier. All right, this is the box plot we're going to be talking about. The box plot, unlike a histogram, has the concept of quartiles and interquartile range and even outliers etched into its DNA. All right, it makes great use of those principles, and it's a nice, simple, elegant graph. All right, so the box plot, first utilized by John Tukey, American mathematician, lived during the 20th century, is an efficient and helpful way of summarizing data. Box plot utilizes the quartiles to map the middle 50% of the data, utilizes the interquartile range to identify outliers, all in one picture. Really awesome. We have the interquartile range explicitly in the box, and then we have these fellas out here, which are the whiskers. This talks about the other data beyond Q3 and beyond Q1, but are within that 1.5 interquartile ranges on either side. Everything past that counts as an outlier. This bar right here is the highest data value that is not an outlier. This bar right here constitutes the lowest data value that is not an outlier. It's a really convenient graph, and you'll be making these mostly on the calculator, but also sometimes by hand, especially in the free response. All right, so here's John Tukey. And if you're wondering about why it's 1.5 interquartile ranges, this is his reasoning. All right, box plots and histograms. Here we go. So, note that the histogram and the box plot of the data both speak to the nature of the distribution, but they highlight different things. They highlight different aspects. The distribution is symmetric and bell-shaped. All right, now we're not going to see that in the box plot. You can make an argument that it's there, but it's not explicit. Box plots are not very good at giving you an idea of the shape of data, not at least as good as a histogram. All right. However, the distribution has a handful of outliers, especially on the lower end. That is not clearly indicated in the histogram. We don't know what to make of these values around here. We also don't know what to make of the values up here. All right. Are they outliers? Are they not? Well, apparently there are a few outliers down here and one up there. So clearly in the box plot we have outliers, but we would not be able to tell that immediately from our histogram. It seems like a bit of a close call. All right. 5-number summary and box plots. This is a way of making a box plot given a set of data. These values here are for reference. We're going to be building a box plot, keeping these data values in mind, and keeping in mind that these are not the only data values we're considering. There are some of them may not even be data values. The median doesn't need to be a data value. Neither does Q3 or Q1. But this is in the context of a large set of data. This is the earthquake data. Okay, so consider the 5-number summary to the right. This can help us to construct a box plot, or at least to understand why the box plot we're constructing makes sense. So box plots can be horizontal or vertical. We're going to use a vertical box plot for this example. This is what our textbook uses. This is right out of your textbook. So here we go. So to construct a box plot, we're going to create a box like the one to the right, okay? This one right here, we're going to be indicating Q1, Q2, and Q3. So Q2 is in the middle, Q1 is at the bottom since this is a vertically inclined box plot. And here's Q3. Very good. For every box plot you make, you want to make sure that there is a number line. This time we have a vertically inclined number line, just for reference. So for convenience sake, this is a little detail that you keep for a little while and then you get rid of at the end. We're going to create fences with dotted lines perpendicular to the axis, that is your number line, at Q1 minus 1.5 interquartile ranges and Q3 plus 1.5 interquartile ranges. Okay? So we figure out what those values are. Q1 minus 1.5 IQR and Q3 plus 1.5 IQR. And we're just going to put marks where those values would be. Now, that's not part of your box plot, but that does help you for your next step. All right? They are not included in the box plot, but are useful for creating the whiskers. Those are the extremities of the box plot. Right? Step 3, we're going to create whiskers by locating the highest and lowest data values that are within the fences. All right. So this is where we would need a little context. We would need to see what the highest data value is that is not an outlier and the lowest data value that's not an outlier. Okay. So apparently the highest data value that's not an outlier is in the upper 8s, all right? And the lowest data value that's not an outlier is somewhere around 5.5. So we put little bars right there, and the fences have now served their purposes. We can erase them and move on. Last step is to indicate all values outside the whiskers, all right? Everything that is not within the whiskers now is automatically an outlier, and that is part of the power of a box plot. That's why we plot these fences in the first place. Everything outside of the box plot right here, all these little dots above and below, they constitute outliers. All right, so let's make a box plot. Below is a list of the number of bugs caught by 25 children at a summer camp. We're going to make a box plot based on this information by hand and on the graphing calculator. Now, if you're interested in the book's way of doing this, you can look at page 55. I'm going to be doing a little demo right after this slide, however, so you can stay tuned for that. But try to make a box plot on your own, and then you can compare your work with mine. Pause the video and give it a go. Okay, let's look at this box plot. So there are no outliers in this box plot here. We see that there is the lowest value 12 and the highest value 29. They are both within 1.5 interquartile ranges from Q1 and Q3 respectively. So there are no little dots at the extremities. There are no outliers. So there we go. Unlike our previous example, no outliers for to speak of. We have a Q1 of 19.5, a Q2 of 22, and a Q3 of 25. A lot of the time, the number line consists of all of the values over the spread of the data. I just included key numbers just so things wouldn't get too crowded. All right? And yes, indeed, 12 is greater than 19.5 minus 1.5 interquartile ranges. If you were to compute the interquartile range, it is 5.5. 1.5 interquartile ranges is 7.75, meaning that 19.5 minus 1.5 interquartile ranges is 11.75. So 12 just barely makes it. All right, 12 is not an outlier. All right. For the next slide, we're going to see how to do all this on the graphing calculator. All right, here's the calculator. If we were to go into Stat, then into Edit, we see that we already have our list. Perfect. So I'm going to go into Second, Stat Plot, and go to Plot 1, which is already on. Very good. Now I'm going to go to Type. I'm going to scroll right until I get to this one right here. Now this one has two little dots, and it looks kind of like a little box plot here. That's important. This is a box plot that acknowledges outliers. Okay? So I'm going to go to, just as before, we're going to go to Zoom, and we're going to go all the way down to Zoom Stat, or you'll probably know this very soon. You go to Zoom 9, and you'll see the box plot right here. And if you are curious about what each of these, the lowest value, the highest value, Q1, Q2, Q3 are, you can go into Stat, and you can go to Calc, and you can see one variable statistics, okay? So you got your box plot. We see a little bit about the data from that, but now we're going to go to one variable statistics. We're going to do this a lot. List is list 1. Very good. Scroll down to calculate. Frequency list. Don't worry about it. All right, and so we compute a whole lot of information. We need to scroll down to get to the good stuff here. We have Q1 is 19.5. The median, or Q2, is 22. Q3 is 25. Max X, that is the highest value, is 29. And we have min X is 12. All right, so that's your 5-number summary, lowest, highest, and Q1, Q2, and Q3. Very good. So now you know how to do this on a calculator.